Great, I think we're on YouTube now. Hey everyone, welcome to this evening's talk. Thank you so much to everybody for joining. Before I hand over, I'm just going to give a quick introduction to Coding Black Females in case this is your first event. So our mission is to grow the community of Black women in software development and in technical roles, and that's all the way from entry level to executive level. We try to remove the barriers to enter the industry and progress within roles. So yeah, I'd like to welcome Beyond Words, who are going to be doing a talk on coding for data analysis. Becca, if you'd like to start introducing.
Thank you, Jessie. Lovely to be here with you all. So I'll probably kick off by starting the tech of it and presenting the slides, and then I'll do a little intros as we go through. So let me kick off by sharing my screen. Okay, so I'm Becca. I'm a project manager at Beyond Words, and we're here today to give you some insight into the kinds of coding and data kind of development work that happens at a data design studio like Beyond Words. Full disclosure, you probably hear the sirens in the background, so apologies, I'm on a main road. Full disclosure, I never knew what a data design studio or a data visualization studio did before I started working at Beyond Words. So I'm hoping this talk will be useful for everyone, myself included. And I'll give you a short intro to our work, first of all, and then I'll introduce you to the team here. So let's kick off. So pre-pandemic, we're normally all found in a studio in Shoreditch. Our team is made up of designers, journalists, developers, and animators. Our work involves transforming data into something that's visual and that anyone can relate to and understand. To give you one example, we're currently working with the World Health Organization, helping them communicate their data around global health and obviously COVID-19 at the moment. So we create data-driven content pretty much on any platform you could think of, anything from digital interactives and presentations through to print and physical installations. And I'll show you a short little snippet of an animation that just gives you a little intro to our work and the kinds of things we make. And so that's just a little snippet of the different data visualizations we create. But over the next 30 minutes or so, you'll hear from our designer, Isabel, our data analyst, Scott, and our technical director, Richard. We're going to cover using Python to scrape and organize data, using R to analyze, plot, and automate data, and building out our own data tools. We'll show you some personal studio projects and projects that never saw the light of day, as well as client projects that did. And as we go along, everyone should feel free to put any questions they have into the chat. If there's a moment, I'll raise them with the team and we'll see if we can answer them as we go along. If not, we'll come back to them at the end and there'll be time at the end for questions. And on that note, let me hand over to Isabel.
Perfect. Hi, everyone. I'm a senior designer at Beyond Word Studio. So I work with editors and analysts like Scott to bring their ideas and stories to life in a visual way. Oops. And then if designing for web, I'll work with developers like Rich and he'll build and bring my designs to life online. My background is actually in graphic design, but I do have a master's in data science that's allowed me to expand my role to include more data analysis projects. And I learned Python while completing that master's. So that's the language that I personally use for all my data work, and that's why I'll be speaking about it today. I'm going to cover a bit of browser automation and using APIs for data collection and a bit of scraping, some cleaning and structuring data, and then lastly, some file organization as well. If it decides to go. There we go. So the first project I'm going to talk about was actually an internal studio project we worked on about 3 years ago. It was looking at various data sets that focused on the effects of climate change. It was going to be this big interactive storytelling piece with different sections that explored each data topic. And for one of the particular sections, we actually wanted to look at temperature predictions for all countries globally across, like looking at different emission scenarios. And so we started by looking at World Bank. They're a fantastic source of data and they have tons of data sets that are all really easily accessible through their data portal. And they had all the data that we needed for this project. So that's what the screenshot is showing you. So the issue that we faced was basically that in order to download all the data we needed, we wanted to look at 3 variables across 230 countries and then 2 scenarios, which was the low and high emissions. And in order to grab all this data, we had to manually submit this form almost 1,400 times. So we decided to use Python to automate the process and download all the data that we needed. For this particular project with Python, if I can go to the next slide, there we go. I use the Selenium package, which is a browser automation library. And this allows Python to interact with a website in a very human way. It's really easy to use. It often just involves directing Python to a website and then to an elements XPath that you want to control, which you can find in the inspection mode of any website. So in this particular snippet, I'm basically telling Selenium, I'm directing it to the URL, which is the World Bank data portal that you saw in the previous slide. And then I've told it to select the various options in the dropdowns and then loop through all of the countries in the data set and download the data. And so you can see that I'm kind of printing the countries as it's looping through, so I can see if it gets stuck anywhere. And then on the right is the complete set of data, which was around 1,380 Excel files in the end. So this isn't a typical example of scraping data since the data is available for download anyways. And it's always important to look at the terms and conditions of pages you're collecting data from. For example, Instagram and Twitter have pretty strict rules against scraper and browser automation, but a lot of times they have APIs available, which I'll touch on a little bit on the next project. And it's also really good practice to build in pause times as well, so as not to overwhelm the server when you're scraping data. Unfortunately, this project never made it live, but this is an example of how the data sets we collected are then transformed into a data visualization. This design I actually didn't work on personally, but it was for a section of the interactive when we made it to the design phase that was called Ring of Fire. And it's using kind of the visual metaphor of the rings of flames to signify temperature bands. And as the years progressed, the countries kind of animated to fall into as they were getting hotter and falling into those temperature bands. So moving on to a kind of more upbeat, fun internal project. This was about songs played in space. So one of the editors at Beyondwords found this really great PDF that contained all the songs played in space, and she thought it'd be really cool to make it into a Spotify playlist. So it's a publicly available PDF, and it was compiled by Colin Fries of the NASA History Division. And he just collected data for all the wake-up calls played in space. And that's basically when mission control would send through wake-up calls that ended up being turned into song requests from astronauts and their families and friends. And it's a really cool document to read through, just to look at the different songs and who requested them and why the songs were requested. And there's a lot of kind of context around some of the song choices as well. In order to turn this into a clean data set that we could work with, I just started by saving the PDF as a text file and reading it into Python. However, the structure of the PDF was particularly difficult to turn into a clean data frame. It didn't have a consistent methodology for listing the songs or dates or artists. So for example, a song and an artist could be separated by the word by, or a double quotation or a single quotation. And I ended up having to do a lot of cleaning and organizing using regular expressions in Python to get this into a somewhat understandable data frame. And you can see on the right is kind of the start of the data frame taking shape, but you can also see how messy it is. And it took several kind of iterations, a lot of looking at the data manually as well. And it just goes to show how important it is to always kind of keep an eye on the data and what it should be looking at as well, because Python is, only so smart. In the end, we had a database of about 1,200 songs. And from that, we were able to access the Spotify API. And that's really easy. You just have to go through their developer website, you sign up, you get a login credentials, and it tells you exactly how to connect it with Python or how to get access with Python. They have a really great documentation as well. And so what we did was use the song name and the artist from our data frame to search the Spotify API, and that would return a track ID. And the track ID allowed us to access kind of additional information on the songs, which we also started to collect. This was more for future potential projects or visualizations that we might want to look at. You could find stats like danceability, energy, liveliness, and then also get the images for album covers as well. We then use the track ID to tell Python to put those tracks into a Spotify playlist, which again was really simple. And this was all done through using the Spotify documentation. And I just wrote a bit of code that basically told me when a song was successfully added or if it couldn't be found. And then we could look at the song in the data frame and kind of see what the issue is. Did it need to be clean a bit more? Or was it a song that just didn't exist in Spotify? There was a ton of really niche university fight songs that weren't available. And the most popular non-patriotic kind of non-Navy song was What a Wonderful World by Louis Armstrong. And the most popular artist beside the US Marine Band was the Beatles. And in the end, we ended up getting around 36 hours of very patriotic music playing in the office for a little bit. For this next project, which actually made it live, we were commissioned to create a tool that would allow the user to access educational data about thousands of schools. So this was one of the most intensive data projects I've worked on. The data was in pretty terrible condition and needed a huge amount of cleaning and structuring and lots of kind of small problem solving tasks. So for example, the client gave us a huge unstructured database of thousands of images. And that's on, you can see that on the left. The images were named with kind of random numbers and letters. And so you couldn't quite tell what the images was going to be up just by looking at the image name. And then these images were also referenced in kind of the big CSV that we were also working with. So we had the database of images, and then we had the CSV. And in the CSV, one of 8 columns listed the images. So we wanted to use the column headers in our CSV to help us structure, the pile of images that we had in the database, just so that we could make sure that the images were being correctly tagged in the data set. So for example, in the data set, if an image file name was listed under drinking facility, we wanted to make sure that that image in the database was actually showing a drinking facility. And the best way to test this was to reorganize the images into folders that actually told us what we were looking at. So I used various libraries such as Shuttle, OS, and Pathlib, and I was able to create new folders in my Finder since I'm on a Mac, move and copy files. I started out by creating folders in Finder that were named after the column headers in our data set that contained images. I then looped through each of those columns in the data set to grab the image file names. If the file existed in the image database we had, it was then moved into the corresponding folder. So this was kind of a small task within a huge project, but what it allowed us to do was to go through the files in their new folders and make sure that the images that were appearing made sense within those categories. There were also a couple of image columns that we weren't actually going to show in the front end, so we could just discard those image folders altogether. And with that, I'm actually going to hand over to Scott, who's going to talk a little bit about R, if I can get across to that slide. There we go.
Thanks, Isabel. Hi, everyone. Oh, someone's clicked this one.
I'm just changing remote control to you, Scott. 1 second.
Oh. Cool. Anyways, hi, everyone. I'm Scott. I'm a senior data analyst at Beyond Words. I joined Beyond Words after completing my degree in economics almost 5 years ago. As Becca mentioned at the start of the presentation, we work on a variety of projects, and every project we work on is very different. Sometimes we are supplied data up front, others we do the research ourselves. Sometimes we're working with hundreds of rows of data, sometimes we work with millions of rows of data. As Isabel mentioned, a lot of the data work is tackled up front. A lot of it is getting the data into a usable format. In the following section, we're going to we're going with the assumption that we have pretty clean data. We already have pretty clean data, and we'll touch upon analysis, data plotting, and data automation in R. So I usually do a lot of my analysis in R, but I also use SQL too, depending on the size of the data. So this is an example of the data we work with. It's in long format rather than wide, which is usually our preference. The data looks at the Sustainable Development Goals, or the SDGs. Each country has data broken out by years for multiple indicators with some additional information such as WHO region and World Bank classification. But before starting any analysis, we want to have a quick look at the data, as Isabel mentioned. Although the outputs of these commands are very simple, some of it could just simply be done by looking at the data. This step is crucial to be able to do the following steps, like plotting charts. So, for example, we need to know if the data is being imported correctly. And also we need to know the class of our fields. Has the value column been imported as a numerical value? As if it's not, this could cause us to encounter errors later on. So firstly, let's look at the glimpse command. The glimpse command shows for each column, the first couple of rows of data and the class of that data. The second is the summary. So this slide is, this is another one I tend to do. This is more for numerical columns. It gives the number of rows of data, the values such as the min and the max, the mean and the median, and the quartiles too. Also the number of NA values. So in essence, these commands give us a quick look at the data. Keep skipping twice. There we go. So this slide gives us an indication of how we begin finding stories in data. We have filtered the data by just one indicator, maternal mortality. And we have a very few lines of code to restructure the data to create a summary for each country. The new data frame has the first year of data for that country, the latest year of data for that country, the value in the first year, the value in the last year, the difference, the percentage change, and the compound annual growth rate. This allows us to plot very basic charts like this. So the x-axis looks at the latest year of data, the y-axis looks at the percentage change, and each dot is a country. So in simple terms, this chart shows us where a country is now and how it is changing over time. Even in these basic charts, we can start pulling out stories. For example, the majority of countries are decreasing. Where are the ones that are increasing? Maybe we need to look at coloring the dots by region or income group. Something else that stands out is that some countries with larger values aren't decreasing as fast as some countries with lower values. Maybe we need to look at the health worker density in these countries. Are they struggling with epidemics such as Ebola? This causes us to question the data, such as why, how, etc. A lot of analysis we do is visual, unearthing nuggets of information to explore further. Every story is different. Is there a change over time, a correlation, or even a part to whole? Here are just some of the plots that I've plotted recently. An XY heat map looking at correlation, a violin plot looking at distribution, a deviation or diverging bar, a dot plot or dumbbell chart looking at distribution, small multiple line charts to look at change over time, maps plotting data geographically. In the studio, we tend to do mini projects for our social channels, like Isabel mentioned. Here, we did one to get into the World Cup spirit. We asked every member in the studio to predict all the results in a dynamic Google Sheet. After making predictions for the group stages, it populated the countries that made it to the preceding rounds and so on. Working with a designer and a couple lines of code, once we had figured out the chart we wanted to tell with the story, we transformed the default output into the styled output. We took the styled output from R and did some final touches in Illustrator. We added a title and a stand first. We restructured the key, added axes labels, and we pulled out key stories. These key stories were, for example, people in the studio still had hope that England could win, or we unanimously agreed that two teams would take an early bath. Another studio project that we did was looking at the number of days couples stayed together in Love Island. This is slightly different, as the final asset was an animated GIF. In the code snippet, it highlights that very few lines of code are needed to produce animated charts in R. Similarly to above, I worked with designer, Isabel in fact, to get the output, the final output as close to the finished mockup as possible. We worked on everything from chart device, label placement, font, colors, etc. This chart was done when the bar chart race were the in chart to do, but it works really nicely with this data. We wanted to see if the winner was just simply the couple that spent the most time together. As you can see, this piece is very similar to the styled output on the previous page. The finishing touches we did were adding a title, which also doubles up as a key, limiting the number of couples to the top 5, and adding a nice little surprise with an emojis at the end, which we'll see now. Another popular request that we get from clients is plotting data geographically. Here you can see very little lines of code is needed to plot a basic map in R. R allows us to plot maps to varying degrees of granularity. For example, global maps plotted by country, which is the one in the middle. Country maps plotted to a state/district level, which you'll see on the left, that looks at stunting in Nigeria. Maps plotted to individual coordinates, either down to the pixel, which you can see on the right, that looks at malaria in Africa. However, maps can be a very sensitive and problematic subject for some of our clients. Certain sensitivities around borders and disputed territories are key. To overcome this, sometimes clients provide us with shapefiles that include maps with disputed borders and territories already marked, which are easily uploaded into R. Finally, another time efficiency of creating charts in R is looping. So similar to what Isabel looked at above, what this allows us to do is once we have the code to produce a chart for a single year, for example, you can easily create a loop around this code to replicate the visual over all the other years in the data. These particular charts look at the difference in cause of death by age group over time. And this can be done across any parameter, which is very handy. Another interesting data automation project that we recently worked on for a leading news agency, although it wasn't done in R, it refers to data automation, and I had not done something like this before. The data automatically updates every day, and the process is as follows. We grabbed the latest data file from an S3 bucket and transferred it to Google Cloud Storage in BigQuery. We then ran a script or a macro script on the data that does very simple formatting and outputs the new data to a table in BigQuery. We then run scheduled queries on the new data to update the main table used in the dashboard. I'm now going to pass you across to Richard, who will take you through the next section. Yeah, you might want to see if he has to unmute before he gets the control.
Yeah, he's now got control.
Hey, sorry, I couldn't unmute myself.
No worries.
Hey, so I'm Richard, Technical Director here at Beyond Words Studio. Just get back to the beginning of the slides. Let's jump forward a bit. Great. So in the studio, we often find ourselves working with large, rapidly changing data sets, as sort of Isabel and Scott is sort of taking you through. We often produce multiple versions of charts while dealing with thousands of rows of data. As Becca introduced, we produce everything from static images, full-blown websites through to animations. And when we're doing them, we need to be as efficient and consistent as possible. One of the ways we do this is by building our own internal tools. These range from small front-end applications to quickly produce an SVG graphic, command line programs to automate an often repeated task, or even plugins for design software. Over the next few slides, I'm going to take you through a couple of examples of things that we've built recently. A few years ago, we did a project for Facebook based on some research they did on families. And the main deliverable was a sort of standalone microsite that consolidated the outcomes of this research. The site was built as a single page application written using React. And as part of the deliverables, the client wanted us to give the users the ability to download PNG assets of all the charts. As the site was multilingual of 4 different languages, with data provided by 7 countries, and it was split into 31 sections, and with the ability to cut it by 4 different filters. That left us with a lot of charts to be produced. Obviously, having a designer creating them by hand would not only be time consuming, but also prone to errors. We're also constrained technological by only being able to develop a static site and not have any sort of backend servers as part of this. So instead, we wrote a small Node.js command line tool that would allow us to load a site, spider the pages, capture part of the DOM, and then save the rendered output to a series of optimized PNGs. This meant that the production of these assets only took around 10 minutes rather than days and days of a designer's time. And when an update to the data came in at the last minute, we were able to reproduce these charts and still deliver the project on time. The next tool I'm going to show you grew naturally out of a series of repeat projects for the same client. These projects always required the analysis of survey data, which contained a mixture of single choice, multiple choice, and free text answers. Isabel had been working on these and started to develop her own process for cleaning and analyzing the data. And even though we have Git repositories to share the code, the issue is that when someone else picked it up, who either didn't know Python or wasn't familiar with the process, they often ended up sort of redoing similar work. And where possible, we also like to produce Google Sheets of working data or narrative stories so that the editors, designers, or in fact anyone in the studio can find about the data and where it needs to go. This led to the idea of creating an actual tool with a bit of a more intuitive front end to help us analyze the data immediately after receiving it. So together, Isabel and one of our developers created the Csv Explorer. It allows anyone in the studio to quickly get a top-level analysis of survey data, as well as allowing them to deep dive into the data and see where the interesting data stories lie. Technically, it's a static React single-page application with custom charts created using the D3 library. There's a small build process that sits in the background that cleans and transforms the client CSV. And this build automatically runs when anyone adds a new CSV to the repository. The tool also allows us to export the data in a format ready for the developer when building the final web page. And by building this tool, we've managed to sort of speed up the process of analyzing the data. But it's also allowed us to be confident that each survey is analyzed in the same way and also hand off to developers in a consistent format. You'll notice over the 3 parts of this talk, we've used a mixture of different languages. In the studio, we don't tend to use one language or one tool or one technique even, but we rather choose the right thing for the job that we've investigated. And with that, I'll pass back to Becca for any questions.
Thanks, Rich. So yeah, that is us done. And any questions you have, we'll be more than welcome to hear them. As we've kind of covered, we've kind of given you a taster of what we might do with different coding languages in the studio. We haven't looked at all at the kind of front end build side of things, but just to give you a snippet and an understanding as to the kind of different tools that are used in a data visualization studio. So we hope that that was helpful for this. And I'll stop presenting now and we can see if there's any questions. One from Faith, what makes a good data set? Isabel?
Oh, I think this really depends on the client, and probably Scott can speak on this as well. For me, the best thing about a data set is usually that it's clean. That just kind of minimizes the work that we have to do up front. And anytime we receive a data set from a client, we can either get something that's kind of in perfect condition that's ready to use. That's usually the least likely scenario. And then oftentimes we actually get data that maybe even looks clean, but on kind of further digging, we have to start kind of tidying things up. And that is actually quite a long part of the process, I find, is just the front end part as well. I don't know, Scott, if you have anything you want to add to that.
Yeah, like you said, it completely depends on the project we're doing. But one thing that I like as well is it's not limited to what the client wants to tell. So for example, if they have a fixed story in mind and they have data for that fixed story and they just supply that data, that often doesn't utilize some of the skills that we have by contextualizing that data, bringing in something that they might not have thought of. So although it's good to have a clear picture in mind of what their vision is. It's not great if they limit the data set to just that vision. So yeah, that's mainly, and like Isabel said, yeah, clean data is always very handy, but yeah, we have to do a lot of the cleaning anyway, so this is.
And which language do you prefer using, Python or R? I thought I might get this one.
Python?
I can start. So yeah, when we split this out, we thought we would get this question. We weren't trying to imply that scraping data or cleaning data was better in Python, and then plotting and analyzing data was better in R. I think it's just a personal preference. Whatever someone can do in R, they can do in Python just as easily. But yeah, I personally prefer R because that's the one I went down, but Isabel will definitely be going the opposite.
Yeah, I mean, I prefer Python because I'm better at it, but I do think that I will say that a lot of people in the data viz industry, I've noticed, tend to use R. And like Scott said, really, you can do anything you can do in one, you can do in the other. But I think sometimes people in data viz end up using R for kind of, I think, more of the being able to produce better finished outputs in less amount of code, basically. But still, I really like Python. I think it's great, and it's kind of straightforward to pick up as well.
Yeah, it's got a nice user interface, hasn't it?
Yeah.
Another lovely question. What are the biggest challenges you come across working with customer data? Isabel, you want to give that one a shot?
Yeah, I think if I'm kind of interpreting this question correctly, are we talking about more of like client data or actually customer specific data? I think maybe if it is client data, definitely the challenges that I face, again, touching on this, and like I would probably mention it all the time, but it's the cleaning aspect of it is usually just, oh, thank you, client data. Yeah, so that is usually the most time consuming part, and it always takes longer than what you think as well. So that's kind of personally the biggest challenge. I actually don't work with data as much as, say, Scott. I think like probably only 20% of my job is actually dealing with data. So I get work on very specific projects. And actually the project that Rich spoke about, which was the survey analysis tool, and kind of what he mentioned, how that was born out of doing the process over and over again, but also the data that we received from that client was survey data. And I found that incredibly tricky to get into a format that we could start to kind of analyze it and ask it questions. So for me personally, the biggest challenges is always cleaning, and then also trying to figure out what format that data needs to be in order to move it either into the visualization stage or the kind of asking questions and analysis stage. I don't know, Scott. Talk more.
Yeah, I agree with that. And another interesting thing is because we work with so many different clients. So for example, we could be working with an accountancy firm one week, and obviously intertwined projects, but accountancy to like global health it's trying to get enough detail from the client that you understand their data as much as they understand it. And that obviously is quite time consuming and takes a lot of time to digest the data before you can then start looking and pulling out these key stories. So yeah, that's definitely something else that is always a little bit tricky with customer data or client data, because they know it so well. And when you don't know it and they're trying to talk you through it, especially like the first time you've seen it without having a little bit of reference, that can always be really hard and get lost a bit. But yeah.
Yeah. We also sometimes get clients that come to us with a data set that they just want us to explore and find the stories from. So that's also challenging, but exciting at the same time. But similar to what Isabel and Scott are saying, it requires like a lot of time up front to clean and understand it before you can then go back, and the client's kind of eager to hear what those stories could be. but you need to make sure you've got that kind of time up front to make that work. Next question is, what makes an effective visualization?
I don't mind starting this, and then I think, yeah, Isabel and Rich can go on from like the 3 stages that we talked about. So personally, it's the story at the start. That is one of the most key things. If you can get the audience attention with just a few bits of information, or whether that be an exploratory piece or an explanatory piece, the story is key to getting the user's attention at the start. Then obviously, if we go into like design, I'll pass that across to Isabel.
Yeah, so kind of going off of what Scott's saying, even, you know, he'll maybe hand over some data, and usually it will have a very clear message, or there's something that we need that data to tell. And so then when we move into design, we often have sketch sessions, which will involve kind of everyone in the projects, you know, project managers, developers, you know, design, everyone. And then we start kind of looking at data visualization devices and how to utilize them to really tell the story that we want to tell. And kind of in terms of it being an effective visualization, one of the most important things is looking at your audience. So, you know, if you're looking at someone like a policymaker, or, you know, maybe that needs to be something a little bit more dry, a little bit more basic, something that's really understandable. If you're working for more of maybe kind of a fun general audience, then you can be a little bit more experimental. So you really, really have to keep an eye on the key story and the audience as well. And those are kind of the most important things. And then they're also all designed under kind of brand guidelines. If a client has one, sometimes you have more freedom, all that kind of thing. So you have to think about all these kind of moving parts as well.
And then I think from a sort of a technical point of view, sort of when we're building sort of an effective data visualization, you know, it needs to be performant. It needs to be sort of fun to use as well. If we have any interaction on it, you know, we need to make sure it animates nicely, it transitions well, and we always sort of work with sort of a design team when we're sort of implementing things on that.
Yeah, and just from a layperson point of view, just has to be quickly readable and understandable. You have to be able to understand what that visualization is communicating, I would say fairly quickly, before you lose your audience. Cool. And any other questions? In that case, I'll hand it back over to Jessie to wrap up. Thank you very much.
Quickly, Becca, before sort of early next year, we have a couple of sort of big projects coming on, and we're going to need a bit of sort of contract help. So if any of you guys are freelancers or do anything like that, please don't hesitate to get in contact with us. I think the
let me
email
pop the email
will
in the chat here.
Be on the chat. We're mostly on the next couple of projects looking for front end people, but you don't need data viz knowledge or anything like that. So if anything we've talked about sounds interesting, please don't hesitate to get in touch.
Great, thank you guys. One quick question from me and for all of you is, how did you know you wanted to get into data visualization? How did you get into it? Yeah, I'd really like to hear.
Good question. Scott, do you want to take that one first?
Yeah, so I, like Becca, didn't know much about data visualization. I joined straight out of university, and I saw this opportunity, and what enticed me to apply was how you can tell or give light to these crazy times, so like climate change, etc., and do work for the good. We work with a lot of clients that are doing work for the good, as we call it. But it's also contextualizing and making data easily understandable and digestible for an audience. It's a challenge, but also something that's very rewarding afterwards.
Isabel?
Yeah, so I mean, I will say, I think anybody you speak to in this industry will have a completely different kind of backstory because it's such a young industry. So there's so many ways to get into it. Personally, I studied, kind of like I mentioned, I studied graphic design at undergrad. And I had a little bit of an inkling kind of towards my final year about data visualization. And just to kind of also quickly answer this question of, do you require a knowledge of maths and stats? I just had a design background. So that was my understanding at that time, was just design. I had a bit of basic kind of understanding of data visualization through like my final year of uni. But when I went to apply to jobs, I actually wasn't applying for specific data viz jobs. I was actually applying to anywhere that would take me and pay me something for an internship. So it actually was kind of a coincidence that I ended up working somewhere at my first job where they put a huge emphasis on data visualization. And you know, the creative director there, that was kind of her bread and butter. So she taught me a lot of what I know. And then I ended up moving to Beyond Word Studio. So you absolutely do not have to have, you know, a strong knowledge of math and stats. It helps, of course, but you can get away with, you know, if you have an eye for design, then you can definitely get away from coming in through straight the design angle. And then I kind of mentioned that I also did the data science master's. So you can come at it also from kind of more of a technical math side as well. So that's how I ended up getting into the industry, I think kind of by luck a little bit.
Well, I'm Rich. I'm interested to hear your answer to that one as well.
Oh yeah, so yeah, I'm sort of a bit like the other two, sort of fell into it a bit. So I was a contract developer for a good few years, just sort of working on sort of front end and back end tools, and then started doing some contracts a bit more in the sort of data viz sort of front end thing, and then just went from there. So, you know, one of the things I like about it is you can take, as sort of Scott and Isabel have mentioned, sort of take a data set and turn it into something that's a story or something that people can interact with or play with, and really sort of get into the data. So it's definitely a sort of interesting thing that allows you to work with.
Cool. And from just my point of view, I was not looking for data visualization work particularly, but there are really interesting projects where you learn a lot and you get to work for some really interesting clients. Like Scott said, that are often in the world doing things for good. We work with Gates Foundation, we work with Women's World Banking, we work with World Health Organization, like really big, interesting clients with lots of interesting data. So that's kind of the main draw for me. Another question in the chat says, oh, your role's London based. They have been, up until recently, everyone's been in the studio. But during lockdown, we have taken on another designer who was kind of all working remotely as well at the moment. So I think there's probably potential for future work that's not just London based, especially at the moment now that we're all remote.
Amazing. Thank you so much, guys, for your answers. It's really interesting to hear how different the backgrounds are. And yeah, that data visualization is something that you can get into even without the maths and stats background. So yeah, thank you very much for your talk. It's been great to hear and have a look at some of your projects and see the science behind them as well. Yeah.
Cool, wonderful. It's been lovely to be here with you all. And yeah, like Rich said, do get in touch if you've got questions. Yeah, if you're interested in any kind of work experience, we'd always be interested in hearing from you. And if there's anyone out there that wants to work with us on projects, yeah, do get in touch.
Great. Thank you very much, everybody.
Thanks all.
Bye.
See you later.
Cheers.
Bye-bye.
Bye-bye.